Okay, so today we are going to be looking at second order differentiation. Now, we are looking at second order differentiation. There are two things you need to know. The first of them is what? Is homogeneous equation, and homogeneous equation that is always equal to zero. Always equal to zero. Now, in homogeneous equation, let me give an example. I can say a the square y over the x square plus b the y over the x plus cy is equal to 0. Now, once it's equal to 0, you just know that it's homogeneous equation. And this a, b and c, they are all constant. That means it can be 1, 2, 3, 4, 5, 6 and whatever. So they are all constant. Now, for homogeneous equation, there are three cases. Case 1, they are real and distinct, meaning different roots to auxiliary equation. They have different roots to the auxiliary equation. Homogeneous equation, you must first solve their auxiliary equation first. I'm going to give examples. So now, case 2, they are real and equal roots. They have real and equal roots. If they have real and equal root to auxiliary equation. Now, case 3, they have complex roots to auxiliary equation. These three cases, I'm going to solve them. And show you how it can be applied. Now, when you are solving an auxiliary equation, you must take note of some things. This equation I gave you, you should note that the square y over the x square is equal to m square. Then the y over the x is equal to m, and y is equal to 1. So anyway, you see this, the square y over the x square, when you are solving an auxiliary equation, you will change them to m square, m, and 1. That's how you do it. Now, the second type of equation is second order differentiation is what? Inhomogeneous equation, whereby it is never equal to 0. The equation is never equal to 0. Now, when you have an inhomogeneous equation, or you can call it a non-homogeneous. So now, if you have an inhomogeneous equation, it can never be equal to 0. And if you want to solve this, you must first turn it into an auxiliary equation whereby it is equal to 0 before you now solve. Let's take an example. Let's say solve the square y over the x square minus 5 the y over the x plus 6y is equal to 24. Now we can see right here that this is an non-homogeneous equation because it is equal to 24. It is equal to a constant. So now, this is an non-homogeneous equation, but like I said earlier, if you are solving an non-homogeneous equation, you must first convert it to like a homogeneous equation whereby it's equal to 0, so you'll be able to solve an auxiliary equation first. So now, let's convert it. We know that the square y over the x square for the top is equal to m square. So yes, m square minus 5 the y over the x is what? M. Then plus 6. Y is what? 1. 6 times 1 is 6. Then now put that equal to 0. Because we are turning it into a homogeneous equation so that we'll be able to solve auxiliary equation. So that's what I mean. So now take these two of them because they will turn to a quadratic equation. So in a quadratic equation, you multiply the first and the last term together. So we have 6m squared. So now, when we have something like this, we look for two numbers that when you multiply them together, it will give you 6m. That is actually plus 6m. And when you add them together, it will give us minus 5. So what are the two terms? You can just think of 3 and 2. 3 and 2. 3 and 2. So when you have 3 and 2, now you will not think of the signs that you should use. If you say 3 times 2, that is plus 3 times 2, that is 6. Plus 3 plus 2 is what? 5. It is not minus 5, so this cannot work. If you use minus 3 times 2, that is what? Minus 6. It's giving you minus 6, it's not minus 6. So this one cannot work also. If you use minus 3 times minus 2, that is what? 6. Because minus times minus is plus. Then minus 3 plus minus 2, that is what? Minus 5. So this was what I'm going to use. So now, this minus 5, that was to split into minus 3 and minus 2. So this is we have m squared minus 3m minus 2m plus 6 is equal to 0. Now put this two in brackets. What we divide these two, that is in the two of them, you have m. If m go in m squared, it will remain what? M minus m in 3m is what? 3. Then minus what we divide in these two, that is 2. If 2 go into m, we have m. 2 divided by 6 is 3. 6 divided by 2 is 3. So now minus times plus, that is minus here. The two things in the bracket, they must be the same thing before you know that you are moving in the right order. So it's equal to 0. So you bring the 2 in the bracket, you bring it as 1 equal to 0, or m minus 2 is equal to 0. M minus 2. So now m is equal to 3 or m is equal to 2. So we have actually solved the auxiliary equation like this. Now this is where the cases comes in. The cases, case 1, case 2, case 3. This is where it comes in. Now when you have solved an auxiliary equation like this, you will not take note of the cases, because we have the solution. Y is equal to a exponential m1x plus b exponential m2x. This is for case 1. This is what you use for case 1 when you have solved this. Now for case 2, exponential mx into bracket a plus bx. This is case 2. For case 3, we have y is equal to exponential alpha x into bracket a cos beta x plus b sin beta x. Case 3. Case 3. So how do you know the right case to use? Simple. See this one, when we solved, we got the auxiliary equation, the answer to be m is equal to 3 or m is equal to 2. And if you check your cases, they said real and distinct, they have different roots to auxiliary equation. Now if you check this, their roots are different. Here is 3, here is 2. So it's actually different roots. So this is, we're going with case 1 for this one. Now real and equal roots. So if for instance the answer we got was 3 or 3, that means we're going to use case 2. If it's a complex root, we use case 3. I'll show you an example of that. So now, since it's case 1 we're using, we just take it as y is equal to a exponential m1 is the biggest number. We take it as 3x plus b exponential 2x. Don't think you are done, because this is a non-homogeneous equation. So you are not yet done. So now, in order to continue, you have to take note of things, of some things. Now, sorry, let me show you the things you have to take note of. You have that function of x, if it's equal to k, that means your solution will not be y is equal to c. Yeah, The next one, function of x is equal to x squared. Your solution will now be y is equal to cx squared plus dx plus e. Take note of that. If your function of x is equal to kx, your solution will now be y is equal to cx plus d. Take note of that also. Now, if you have your function of x is equal to k sine x, k sine x, the solution will be y is equal to c sine x plus d cos x. If your function of x is equal to k sine hx, the k and the h, they are actually constants, so the y is now equal to c sine hx plus d cos hx. Last one, if your function of x is equal to e exponential kx, the solution of y is equal to c exponential kx. So now you must take note of these 6 things, because now if you look closely, the equation we're solving is equal to 24, and 24 is just like a constant. There's no sign, there's no cos, there's nothing attached to it, there's no x, there's no y, there's nothing, so it's just a constant. So now we should know that this is what we're going to use. Function of x is equal to k is a constant, so your y is equal to c self is a constant. So now that's what you now take. Since you now do it like this, since your function of x is equal to k, which is also equal to 24, yeah, you now do your y is equal to c. So this is where the other part starts. So now you can take it as equation 1, y is equal to c as equation 1. So let's start. You differentiate y. The y over the x is equal to what? 0. Differentiation of a constant is 0. Just know that. Then the square y over the x square is under 0. So now I can take it as equation 2, equation 3. That's how we do it. Then to me, I like writing down the question back for better understanding. The square y over the x square minus 5 dy over dx plus 6y is equal to 24. Is equal to 24. So now we start solving. The square y over the x square is what? 0 minus 5 y over dx is what? 0. That's what we got. 0 0. So now plus 6. What is your y? Y is equal to c. Let's take out the equation 1. So 6c is equal to 24. 0 0. So 6c is equal to 24 over 6 over 6. Your c is equal to 4. So therefore, take back from equation 1. So therefore your y is equal to 4. So now in your final solution, you have y is equal to a exponential 3x plus b exponential 2x plus 4. So this is your final answer for this particular question. Let's take another question. Solve the square y over dx squared plus 4 dy over dx plus 9y is equal to 2 sine 4x. We're going to solve this right now. So now let's do this. Like I said earlier, I've done it into the auxiliary form. So this is what? M square plus 4m plus 9 is equal to 0. And normally we knew that this is a quadratic equation, and we're meant to multiply these two and return to 9m square. But in this case, this quadratic equation, you cannot find anything factorizable, because what will you times that will give you 9, and when you add them will give you 4? There's nothing like that. So now we will introduce what they call the formula method, which is minus b plus or minus square root b square minus 4ac over 2a. Now this m is your ia, 4 is your b, c. That's how you do it. So now minus b, that is minus 4. Minus 4 plus or minus square root. What is your b? 4, so 4 squared minus 4. What is your a? Times 1 times c is what? 9 over 2a. 2a, what is your a? Times 1. So minus 4 plus or minus 16. How did I get 16? 4 squared 16 minus 9 times 4 is 36 all over 2. So now minus 4 plus or minus 16 minus 36, that's what? Minus 20 all over 2. So now in complex numbers, you have to recall that root of minus 1 is equal to j. This is what you do in complex numbers. So when you recall this, you will not be able to solve. Let me just take it here. So now we have that minus 4 plus or minus root minus 1. Now this root of minus 1, just bringing it out here as root minus 1 times root 20 all over 2. So now we have that minus 4 plus or minus root 20. Root of minus 1 is what? Is j. So root 20j all over 2. So now root 20, you look for a perfect square. And when you multiply with another number, can go. So square root of 4 times 5. 4 is a perfect square. How do I know? How do I know that 4 is a perfect square? It's simple. 1 times 1, 1. So 1 is a perfect square. 2 times 2, 4. 2 is a perfect square. Get that? 3 times 3, 9. 9. So this is how you know that this is a perfect square. 4 times 4, 16. 16 is a perfect square. 5 times 5, 25. 25 is a perfect square. So that's how you know perfect squares. So now, so that is equal to square root of 4 is actually 2 root 5. So let's continue. So we have minus 4 plus or minus 2 root 5j all over 2. So now 2 will go into all of them. So 2 in 4, we have minus 2 plus or minus root 5j. This is what you have. So now, in the case of this one, you have to do m is equal to alpha plus or minus j beta. So now, you know that this m is equal to normally. So your alpha is taking the place of minus 2 and your beta is taking the place of minus root 5. So now this is a case 3 form. How do I know that it is a case 3? Now, how do I know? So now, this is how I know. If you look at case 3, you see that they have complex roots to auxiliary equation. Complex roots. Now this is a complex root. How do I know it's a complex root? Why am I saying j? J is making it a complex root. So now we're going to use the solution for a complex root. And what is that solution? Y is equal to exponential alpha. What is your alpha? Root 2. Having minus 2. Minus 2x into bracket a plus, what is your beta? Root 5. Root 5x plus b sine root 5x. So now this is your solution for this because it is a complex root. So now, like we know, we are not done because it's an inhomogeneous equation, so you have to solve the other part. So let's continue. So from the equation, we have that our f of x is equal to what? 2 sine 4x. That's what we have. Our f of x is equal to 2 sine 4x. So now, if you notice very well, our f of x is equal to 2 sine 4x. Now look at the rules I gave you before. 2 sine 4x. I said k and h, they are all constant. So this is actually, so this is the solution we use. Y is equal to c sine hx plus d sine hx, then you now turn those hx to 4x. So now our solution becomes y is equal to c sine 4x or cos 4x is anyway again plus d cos 4x, and this is our equation 1. So now, like we did before, we differentiate the y over dx. The y over dx, that is what? So now we what? Differentiate 4x first. Differentiate 4x, we have 4. So that is 4. Now differentiate sine, we have cos. Get that? So now write down the 4x again. 4x is actually 4c. This c, you multiply the first one you differentiated with it, like it, then plus differentiate cos, we have minus sine. Differentiate 4x, we have 4, that is 4d and 4x. So now d square y over dx square, differentiate it again. Now differentiate this cos, we have minus sine also, minus sine. Differentiate this 4, this 4x, we have 4 times this 4, we have 16, and that is minus 16c sine 4x, then minus differentiate sine, we have cos 4x, we have 4 times 4, 16, and minus 16d cos 4x. So now I've gotten it. So now let's rewrite our equation again. That is what? D square y over dx square plus 4 dy over dx plus 9y is equal to 2 sine 4x. So now what is our d square y over dx square? That is minus 16 c sine 4x minus 16d cos 4x, then plus 4 into bracket dy over dx. What is it? Is it here? We have 4c cos 4x minus, it's actually minus because minus times plus, like minus, so minus 4d sine 4x, then plus 9 what? 9y. What is our y? Is it? So c sine 4x plus d cos 4x close the bracket is all equal to 2 sine 4x. So you have to open the bracket, it says open bracket. So we have minus 16c sine 4x minus 16d cos 4x plus 16c cos 4x minus 16d sine 4x plus 9c sine 4x plus 9d cos 4x. Now that is the thing, we open up the bracket, is equal to 2 sine 4x. 2 sine 4x, that is what I would do. So now when you have it like this, you have to like collect like terms. The one that have sine will go to one side, the one that does not have, that have cos will go to the other side. So that was what to do now. That was what to do. I will now do right hand side is equal to left hand side. So that's what I'm trying to do now. So now let me take the one that has sign. So the one that has sign, I know that minus 16c sine 4x, that's sign. Phew. This one also has sign, minus 16d sine 4x. Then this one also has sign, plus 9c sine 4x is equal to 2 sine 4x. Now let me do the one for the cos. I'm trying to do this to form a simultaneous equation. So this one has cos minus 16d cos 4x plus 16c cos 4x then plus 9d cos 4x is equal to 2 sine 4x. Right. So now you see that this sine 4x, yeah, sine 4x, sine 4x, sine 4x. So actually sine 4x is equal to 2 because yeah, it's 2. But this one, they are cos 4x. They don't have, this place is not equal to cos 4x, so it's equal to 0. So we can just take it as minus 16c minus 16d plus 9c is equal to 2. Simple. Then minus 16d plus 16c plus 9d is equal to 0. As easy as that. So now minus 16c plus 9c, minus 16c plus 9c is actually 7, minus 7. So minus 7c minus 16d is equal to 2. Then minus 7d plus 16c is equal to 0. So I can rearrange this, rearrange it. So this is minus 7c minus 16d is equal to 2. Then bring the 16 to the side. 16c minus 7d is equal to 0. So now this is our, we also solve using simultaneous equation. I want to find c and d now. So now solving this, I'll multiply the up part by, let's say 7, multiply the down part by 16. So now 7 times 7 will have 49 minus 49c minus 7 times 16. 7 times 16, let's press the calculator. 7 times 16, 112. So we have 112. 112d is equal to 7 times 2, that is 14. So now 16 times 16, we have 256. Press my calculator. 256c. 16 times 7, I have 112 also, minus 112d is equal to 0. So now I have to think, which sign will I put outside that will make this d to cancel? Because now you can see it's 112, 112. If I put minus here, minus times minus will give us plus, so that this two can cancel. But if I put plus here, plus times minus is minus, so this one just add up and give you minus something. So that let's do this. We have minus 49 minus 256 minus 305 and minus 305. C is equal to what? 14. So divide both sides by minus 305. C is actually equal to minus 14 over 305. So now you insert this into any equation. Let's say equation 1, insert c is equal to minus 14 over 305 into equation 1. So now with our equation 1, write it out again. Minus 7c minus 16d is equal to 2. So now minus 7 into bracket minus 14 over 305 minus 16d is equal to 2. We're trying to find d. So now 7 times 14, 98. Like 98 over 305 minus 16d is equal to 2. We have that minus 16d is equal to 2 minus 305. 2 minus 98, sorry, over 305. Here's over 1. So this is it. Can you do CM? Can you press a calculator? 2 minus 98 over 305 times 512 over 305. So now we have minus 16d is equal to 512 over 305. Divide both sides by minus 16. So this will now be d is equal to 512 over 305 times 1 over minus 16. So 305 times 16, that is 4,000. So d is equal to 512 over 4880 minus sign here, and divide again. 512 4880 32 over 305. So d is equal to what? 32 over 305.